Hey everyone and welcome. Today we're going to jump into a really cool way to yank mathematics right out of the textbook and put it, well, right into our hands. We're going to explore how 3D design can totally change the way we see, touch, and really understand numbers.
So, I want to kick things off with a question that gets right to the heart of it all. When is math more than just a bunch of symbols on a page? Because, let's be honest, for a lot of us, math can feel super abstract, kind of distant, almost like it's a language you're not supposed to understand.
And here it is, the answer. Math becomes real, it becomes intuitive, and honestly, kind of fun when it's something you can actually hold in your hand. The big challenge has always been, how do you build a bridge from an abstract idea to a real physical thing? Well, today, we're looking at a tool that does exactly that.
Okay, so the tool that builds this bridge is called Tinkercad. And believe me, it opens up a whole new world for learning math.
And you want to know the best part? It's a completely free and shockingly simple tool that lets basically anyone turn their digital ideas into actual physical objects. You don't need to be an engineer or a pro designer to get started. It's really built for everyone as a way in.
What's so cool about Tinkercad is just how versatile it is. It's not just one thing. You've got 3D design, where you build with shapes. That's what we're going to dig into today. But then there's also circuits, where you can explore electronics, connecting math to science. And there's even code blocks, where you generate designs using code, which is all about geometry and patterns. It's like a whole creative playground.
And this right here, this brings us to the core idea of this whole explainer. This is the big aha moment. It turns out that when you're designing something in 3D, you're secretly doing math the entire time.
I'm serious. Every single click, every little adjustment, every move you make on that screen, it's a direct mathematical operation. You're not just dragging shapes around, you are performing calculations.
This quote from the source material just hits the nail on the head. Think about it. When you're scaling an object to make it bigger or smaller, you're actually doing multiplication. When you're rotating it, you're dealing with degrees and geometry. And even when you group a bunch of shapes together, you're using the principles of set theory. It's all math.
This table lays it all out perfectly. Every intuitive design action you see on the left has a direct partner, a core math concept on the right. So when a student resizes an object, they're not just clicking and dragging, they're intuitively working with multiplication and proportions. When they use that whole tool to cut a piece out of a shape, they are physically experiencing subtraction. This is where the learning becomes so powerful, because it's subconscious.
Okay, so that's the theory, right? But what does this actually look like in a classroom? Let's check out how this idea comes to life with a really simple but powerful challenge, creating number blocks.
Now, what the students are creating here is what's known as a math manipulative. And this is key. It's not just a toy. It's a tool, an object that is specifically designed to help someone get a math concept by literally feeling it out and moving it around.
And the challenge itself? It's wonderfully straightforward. First, you just create a simple rectangular base. Second, you use that subtraction tool we just talked about to cut out holes that represent a specific number. And finally, you can get creative and add some details. It's a perfect first project for any beginner.
But just look at the learning goals this simple little object manages to achieve. By holding these blocks, a kid can physically see that a 2-block and a 3-block put together are the exact same size as a 5-block. That's equivalence. They can visualize grouping, help with their counting, and even start to explore bigger ideas like scale and symmetry. It's so powerful.
Of course, the magic doesn't just stop on the computer screen. The final step in all this is to bring that digital design into the real world.
This all happens through the 3D printing workflow. First, the design gets saved as a special file called an STL. Then a piece of software called a slicer cuts that design into thousands of super thin layers that the printer can understand. And finally, the printer gets to work, building the object layer by tiny layer until it's a real thing you can pick up. And that entire process, from the first spark of an idea to holding that final physical object, it's incredible. It seamlessly connects abstract math to creativity, to real-world problem solving, and even to the basics of engineering.
And just remember, everything we've looked at today is focused on just one of this tool's creative pathways. You could take these exact same ideas and use them to explore applied math with circuits or the geometry of patterns with code blocks. The potential for making learning something you can touch and feel is just huge.
So, if you take one thing away from our explainer today, let it be this. With simple, accessible tools, we can completely transform math from some abstract subject in a book into a tangible, creative, and really engaging problem-solving experience. And that leaves us with a final question. for you to think about. Whether you're a teacher or a parent or just someone who loves to learn, how could you use an approach like this to make math more visible, more interactive, and more real in your world?